Now, the second part of energy chapter 3, which is the topic of energy. So what is energy? Energy is defined as capacity to do work. And our textbook lists those basic concepts of work, kinetic energy, which is works in motion, and the potential energy, which is shown in this dam, like the water restored in the height, and when it flows down, a lot of energy was released. That's called potential energy. And basically, the four forms of energy. The first one is mechanical energy. Second is chemical energy. Third one is electrical energy, that is created by moving electrons carried along a wire or any other conductive material. And radiant energy, that is from the sun. And as we think about photosynthesis, all the energy comes from the sun. So the earth is driven by the radiant energy, right? If you think about it, the energy of the sun is restoring plants and get consumed by humans and animals, so we can do our work. So I would say the radiant energy is a fundamental energy of the whole planet. So first, the law of thermodynamics is energy cannot be created or destroyed. Sounds familiar, right? The mass cannot be created or destroyed. So interestingly, the total energy on the planet is also stay the same. It either go this way or that way, go this place or that places, but the total energy is the same. It's a very interesting fact. We just have to learn to accept it. The second law, when energy is converted from one form to another, some of the useful energy is lost. Unfortunately, a lot of useful energy is lost. Entropy and enthalpy. So enthalpy is orderness, okay, and a smaller volume. Entropy is a disorderliness and expanded volume. Example would be like this. So for entropy, I just want you to remember disorderliness. A pile of bricks cannot do anything, and we have to put in energy to make it orderly, such as a chimney or a house. So the chimney and the house can do some type of work, and a pile of bricks cannot. And we have to put in the energy to make it work. The enthalpy, okay, it's not listed in the textbook, but that's the opposite counterpart of entropy. Enthalpy means orderness, functional, less heat. Entropy is disordered, lot of heat. And a lot of heat was just dissipated, and we cannot use the heat to do anything. For example, a car, right? Where the energy comes from, guys? I'm not talking about electrical cars. I'm talking about the traditional car. It comes from the gasoline. So the chemical energy is restored in the gasoline. And then when we combust it, when we burn the gasoline, it could be used to drive the car. So the useful energy is chemical energy and the kinetic energy to turn the wheels. And unfortunately, the efficiency is very low for a traditional car, and a lot of energy is lost in heat and the friction. So now we know heat is dissipated into the environment. It's generated from the chemical reactions or frictions. And the process of becoming disordered coincides with a constant flow of energy toward dilute form of heat. So heat is our enemy, okay? Heat is a disordered, expanded energy, entropy. So for the high quality energy, it can be used to perform useful work such as electricity. And the low quality energy such like heating the ocean is hard to use. But still, low quality energy still has significance in the world, such as regulating our weather and the climate, right? Hurricane is one of the examples. Hurricane cool down the whole planet, so it has a purpose. But unfortunately to our humans, it's very disastrous. And as humans, we can master the low quality energy. We can convert the solar power, the wind power, and the heat in the ocean someday, hopefully, into high quality energy. So that's application of renewable energy, right? If each person on Earth used less energy, there would be less waste heat and other forms of pollution that result from heat conversion. This is very deep. That's why I put it here. Think about cooking. We use electricity or gas, and we burn and we cook. In the ancient times, we just use wood. That efficiency is even lower. And now we use electric stove or we use natural gas, but still a lot of heat was released and we cannot use that heat. So the efficiency of the process is very low. So how does energy affect life? Now I want to introduce this very important concept, trophic levels. Plants, let's start with primary producers. Let's start with a food chain. Okay, so this is more easily understand. If I just tell you trophic level, energy levels, you have no clue. So the primary producer, which is producer, I don't like the word primary producer, just call it producer. Plants transform sunlight into chemical energy through photosynthesis. Some bacteria can do that too. Okay, can conform either sunlight or thermal energy or chemical energy into an ordered higher quality energy. They are called producers. Only 10%, unfortunately, only 10% of the energy from consumed organic matter transfer to the next food chain level, resulting in significant energy cost. So here, let's take a look at the right figure. Sunlight, 100 units going into the plankton. So plankton take a lot of the energy from the sun and form 100 units of energy. And then primary consumer eat the plankton, which is a small fish, and only taking 10 units. Where the 90 units go through respiration, right? The breathing. So the plankton need to survive, so need to breathe. So it break down the energy for itself and released in heat, or it died. It got decomposed, also released as heat. And the same thing, the same thing with the secondary consumer, which is bigger fish eat the small fish. The bigger fish can only use 1 unit of the 100 unit. And when the tertiary consumer eat the big fish, which is a shark, eat the big fish, there's only 0.1 unit of the whole energy will be used. So it's a very wasteful process. If we take advantage of another visual aid, it looks like this. So I don't know what's wrong with my mouse. Where's my mouse? Okay. So let's look at the big green square. That's the energy taken from the sunlight by bacteria or algae or plants. It's that much chunk of energy. When the herbivore eat the producers, okay, when the herbivore eat the producers, only 10% can be used for the herbivore. And when the primary carnivore, which is the secondary, now I know it's a little bit confusing. So when the secondary consumer, which is the primary carnivore, eat the herbivore, and they can only take the 10% of the energy from the herbivore. The same thing with the second herbivore, which is the tertiary consumer, okay? Pay attention. Secondary carnivore is the third consumer. Okay, the tertiary consumer. And you can see from the right side of the figure, in the green arrows, a lot of energy was wasted. I would not say it's wasted, but a lot of them is wasted. Some of them is used by the animals or creature themselves. They take in the energy and release heat. So now, 2 exercises. Pay attention to the 2 exercises so you can make sure you understand the concept 100%. This is testing point. So what is the producer in this figure? The best use of the slides is you pause the slides and do the exercise yourself and then listen to my answers. So who is a producer? First, the trophic level. Now it's much easier to understand what is the first, the second, third, and the fourth trophic level. The first trophic level is the first level immobilize the energy from the sun, right? That is a producer, the plants or bacteria or algae. Algae is a form of the plants. My understanding is. So the grass is the producer, and the mouse is the primary consumer, and the snake is secondary consumer, and the hawk, the eagle, is a tertiary consumer. If the human illegally hunt the hawk or the eagles, they are the quaternary consumer. Now the trophic levels show up. It's quite easier to understand now. So the grass is the first trophic level, mouse is the second, snake is the third, and the eagle is the fourth. And now do this exercise by yourself. I'll see if I need to put this in the discussion post so you all can practice and master this concept, because this is very, very important to understand many concepts later in ecology. Last thing, what I can do, okay, stop wasting energy is the first thing. Conservation of energy, to save use of the energy. I love your go green actions. When you go out of the house, turn off the lights. When you go to bed, turn off the lights. And when you brush your teeth, turn off the water. Those are very, very good go green actions. If everybody can do that every day, we save a lot of energy and resources. That's very healthy for our environment. And you can do a bunch of other things, right, involving the sustainability program of the campus. Understand everything goes somewhere. So when you use those plastics, you know they are not going to disappear, right? They are going to linger on the earth for a long, long time. And the third one is recycle, reduce, reuse, and recycle. That save a lot of energy. So this concludes the second part of my